Welcome to the channel. If you're new, welcome, and if you're returning, welcome back. So in this lesson, we're going to walk through solving systems of nonlinear equations and how we can solve them. And there are different types. Anytime that you have a system that at least one of the equations or functions or relations is not linear, we call them non-linear system. In this case, I have an example up here. The first example, this is a linear system, a linear quadratic system, but it could be any two relations or functions or relation and a function. um, you can have a system and you can go ahead and solve. So let's go ahead and solve this. And the question is, solve this system graphically. Now there are two ways. If you remember from solving systems of linear equations, there was graphic solutions. That means you solve the system graphically. You have to graph the lines and then see the point of intersections if they exist. And also we did algebraically. So in this case, we're going to start with the graphic solution as well. And then for the purpose of this lesson, actually, I will go over how to solve this algebraically as well. So the first thing you need to know for solving this system graphically, which is a line, 2x minus 4, that's a linear function. Y equal to x squared minus 4, that's a quadratic function. These two right here, they are prerequisite knowledge. That means you must know everything about linear functions and everything about quadratic functions. And that means you need to be able to graph these accurately. All right, so let's go ahead and graph that. And we're going to start graphing the line. So when we write the equation y equals to 2x minus 4, you're going to start with the y-intercept, which is -4. Let's go through. So we have -4 right there, okay? And then use the slope, and then you go up. The slope is 2. That means it's 2 over 1, rise over run. So you go up 2 over 1, okay? Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then you do the same thing in the bottom. You go down to the left 1. And these are the set of points that you can draw a line through, and you're going to use your ruler and put a line right through it. Let's do that. And here it is. This is the equation, or the line for the equation y equals to 2x minus 4. You don't have to put it up there, but here it is, and I just want to make sure that you see it. Okay, now let's go ahead and graph the quadratic function, x squared minus 4. We know that the vertex is 0. So let's write up what the vertex is, because that's the important part. 0 minus 4. And we know that expansion compression factor, which is the coefficient in front right here, that's 1. So if a is 1, we can graph this using the pattern of 1, 3, 5, 7. And I'm going to explain what that is in case you have forgotten it. All right, we're going to start with the vertex 0 minus 4, which is right there, and you can see the first point of intersection of the two functions is 0 minus 4. The next one, you go over to the right one and then up 1, because it's congruent to y equal to, so this means it's congruent to the parent function of the quadratic y equal to x squared. Okay, and then the next one, you go over 1. So remember, over 1, up 1, that's 1. The next one, over 1, this time you have to go up 3. All right, so that's the next point right there. And remember, it's symmetric. So while we're doing that, let's do the other side as well. So to the left, and then you do the same thing. You go up to the -2. Again, you go up to the right 1 unit, up 1, that's 1. This is 3. The next one will be, you go over 1, and this one will be 5. So 1, 2, 3, 4, 5. So that's the next point. So you go up 5. So this pattern of 1, 3, 5, that's the regular pattern. And because it's symmetric, you go across, and then you do the 3, 5, which is -3, 5, which is on the other side. And now you go ahead and graph, and I'm going to try to graph this freestyle. So I'm going to use dotted line, do the same. But the point is to see the graph, and then recognize the point of intersection of the graph. Okay, so that's the point of this graph. So the points of intersections are, we have 1 in here, so that coordinate is 0, -4. And the next point of intersection is right here, is 2, 0. You see this line, the kind of a brownish line right here, and then the blue, they intersect at 2, 0. So we got 2 points of intersections right there. So we have the system right here. Now to solve it algebraically, whenever you come across a non-linear system, the best thing to do is substitution. Simple as that. Don't mess around with it. Just do the substitution. So in this case, we're going to substitute x squared minus 4 for y in the first equation and then solve. So what do we have? We're going to have x squared minus 4 must equal to 2x minus 4 because both of them are equal to y. All right, so I can simply do the substitution or set it equal to each other, and then you go ahead and solve now. This is a quadratic equation, x squared. You're going to bring everything to one side and set it equal to 0 and solve this quadratic equation. If it turns out to be a quadratic, in this case it will be. So this case we have -4 and -4, that's 0, and then you have minus 2x and set that equal to 0, and then you solve for x by factoring. That's the easiest way to do that. That's x times x minus 2, set that equal to 0, and then you're going to use the zero product rule. That means either x equals to 0 or x equals to 2. So those are the two x coordinates that they give you the same value for this system. Now we got to go ahead for each one and solve for the y value. So let's start with x equal to 0, and you plug it back into any of the equations that you like. Let's plug it into equation 1, the linear one. We can do both, but notice that when you do that, you get y equals to 2 times 0 minus 4. So therefore y equals to -4. So the coordinate here we have 0, -4. You do the same thing, and visually you can see, you plug in 0 for x, you're going to get 0 squared minus 4 is minus 4, so y equal to -4. So this point is actually a good point test for both. Let's do x equals to 2. You do the same thing, but this time you can put in the second equation, the quadratic one. So y equals to, I'm just randomly doing that. You can choose equation 1, the linear one, doesn't really matter. 2 squared minus 4, and that is 0. So that's 2 comma 0. Now, that's another one, and then you plug it back in there. If you want to check this coordinate or the value for the first equation, just plug it in there. So you say, okay, 2 times 2, right here is 4. 4 minus 4 is 0, so 2, 0 is another solution. So we have another coordinate right there. So we have, here we go, we have the coordinates, we have two coordinates. So now that we have the 2 points, let's go and check the graph, make sure that it works. One was 2, 0 right here, the other one 0, -4, and here are the two solutions that we got that matches the algebraic solution, and we are good to go. Now let's go ahead and solve another system of equation, but this time is quadratic, and we know how to do this. Now you can solve this graphically, but I like to solve this algebraically because algebraically is a very precise process and exact values you will get. With graphing, the graph, unless both graphs are tailored to have integer values for the intersections or solutions, you have to use basically technology to graph this, Desmos, GeoGebra, whatever the graphing technology that you're going to use. So let's just solve this algebraically, and plus that would be a good practice. So to solve this system of quadratic, we have to again use substitution. We're going to set both of these guys to equal to each other because both of these two guys are equal to y and the same value for the y. So let's go ahead and do that. And so x squared minus 4x plus 6, you set that equal to minus x squared plus 4x minus 3, and then you go ahead and solve. When you do this, you bring all the like terms together, so 2x squared and then minus 4x, so we're going to bring the x's together. That would be negative 8x and then negative and then positive 9 because you're adding 3 to both sides. Set that equal to 0. Now Two ways to do this. You can use quadratic formula or you can use factoring. We're going to use quadratic formula. It just makes it faster and easier. That way you don't have to, in case you've forgotten how to factor this, maybe it's not even factorable, by the way. There's a good possibility in here. So the more practice you do, of course, you get better at it. But use the quadratic formula. Let's plug numbers in with the quadratic formula. Here is the quadratic formula as a reminder. You plug numbers in for A, B, and C. Remember, A is 2, B is -8, and C is 9. You plug numbers in, and you will end up getting this quadratic. When you simplify it, you're going to get -8 inside the radical. The radicand is -8. This was the discriminant, right? The nature of root lesson that I did. You may want to go back and check that out. But in this case, this quadratic equation has no real roots, okay? Has no real roots. It has complex roots, but above and beyond the scope of this lesson. So because it doesn't have any real roots, you don't even have any values to go back in there and plug in for y values. So you can assume now safely that these two quadratic functions, they do not intersect, and kind of makes sense because one is upside up parabola, the other one is an upside down parabola. One has got the y-intercept about 6, the other one -3. So unless you graph this accurately and go through the comprehend square and change that to vertex form, or you can use Desmos and you can see that these two graphs do not intersect at all. Therefore, they have no real solutions. So here are the two or three examples that we did. One was graphing, and then we did the algebraic method. The other one, we didn't do the graphing method, but we did algebraic method. And this is the system of non-linear equations. And in this case, we just used quadratic quadratic or linear quadratic. Okay, until next time. If you found this useful, subscribe, like, leave a comment, and hit that notification bell so whenever I post a new video, you'll be notified. Until next time, keep at it.